Hi, I'm Mudinda and I'm here to help you understand maths better for free. Now, matriculants, today we're talking about limits. This is our first video on calculus, and I know that for most matriculants, calculus can be quite daunting. I'm determined to help you understand it better, so please do take out some time to not only watch this part 1, but all the other videos that we will release on the calculus topic. Let's get into it. How do you find the limit? So when you're asked a question like the following, this reads the limit of 2x as x approaches 3, or the limit as x approaches 3 of 2x. Now, in order to find the limit, you can simply plug in the x value of 3 in place of x there. So that's just 2 times 3, meaning the answer is 6. That's as simple as it is. Now, what it actually means, I don't want you to stress about it too much because you don't necessarily have to know it for matric, if I'm being honest. It really only helps if you are in first year and doing maths. But this just means that the function 2x, and I'm going to just provide a rough sketch of what that function looks like. It looks like that. As x approaches 3, so the closer and closer that we get to an x value of 3, this graph gets closer and closer to a y value of 6. That's all that means. Now, we will discuss that more in detail towards the end for your own enrichment, but you really just only have to worry yourself about how to find the limit. And so let's look at more illustrative examples on that. So here we have that the limit of 2x minus 3 as x approaches 5. That's just going to be 2 times 5 minus 3. Now, 2 times 5 is 10. So this is 10 minus 3. So the limit as x approaches 5 of 2x minus 3 is 7. Here's another example. Let me just quickly fix that. Should be p there. The limit of 4p as p approaches negative 2 is 4 times negative 2. In place of p there, I would replace with minus 2. Now 4 times negative 2 is negative 8. So the limit of 4p as p approaches minus 2 is negative 8. Now here we have the following, that what is the limit of 28 as x approaches 10? Well, 28 is not dependent on x. And so no matter what x is, 28 is just 28. In fact, if I were to sketch a graph called y is equal to 28, or it would be at a y value of 28, there would be a horizontal line like that. That's the graph called y is equal to 28. You will agree with me that at every single x value, the y value of this graph is just 28. It is unaffected by what x is. And so that's why the limit of 28 as x approaches 10 is just 28. And this is how you treat the limit of any constant. It's unaffected by the variable x. Great, let's look at some more examples. Now, in this example here, we have the limit of 18 over x as x approaches 3. That's simply going to be 18 over 3. And 18 divided by 3 is 6. So the limit of 18 over x as x approaches 3 is 6. Here we have the limit of minus 2 as x approaches 9. Well, minus 2 is unaffected by x. The answer is just minus 2. Here we have the limit of 2 over x as x approaches 0. Now, I don't know if you know this, matriculants, but you should know it that division by 0 is undefined. You can grab your calculator, put any number and divide it by 0. It'll give you an error. Division by 0 doesn't exist. It's undefined. That's one of the 2 cases of undefineds that you guys learn about in high school. Division by 0 as well as the square root of a negative number. If you take 10 and divide it by 0, your calculator will say that's an error. If you take the square root of a negative number, say the square root of negative 4, your calculator will also say that's an error. So because of this, when you are given something like the limit of 2 over x as x approaches 0, you would say it does not exist. This limit does not exist. Okay. Here we have the limit of 3 over x minus 5 as x approaches 5. If you replace the x value here, x, with 5, you'd get 5 minus 5, meaning the denominator would be 0. And again, we don't have a denominator of 0. In maths, it's undefined. So this limit as well does not exist. Okay, so whenever you get undefined as an answer, you'd say does not exist. But sometimes you can avoid an undefined result. And that's what I want us to look at. So here's an example here, matriculants. We're being asked for the limit of the function called x squared minus 4 over x minus 2 as x approaches 2. If you plug in an x value of 2 there, you'd have a denominator of 2 minus 2, which is 0. And we know that whenever we have a denominator of 2, that would be undefined. But we can actually simplify this fraction here. We can use factorization to simplify that expression. Now, this is something we look at in a previous grade 10 video, using factorization in order to simplify, but I know most of you would be comfortable with that. I'm going to say here, the limit as x approaches 2 of, and I'm going to factorize the numerator x squared minus 4. It's a difference of 2 squares, so I'm going to open 2 brackets, put here x, put here 2 and 2, plus and minus. Now, if you struggle with factorizing using the difference of 2 squares, we also have a video on that. So as you can see here, I haven't done much. I've just factorized this numerator. Then how that helps me is that now this x minus 2 can cancel away with this x minus 2. So what I'm left with is the limit as x approaches 2. This doesn't just disappear. It can only disappear if I plugged in the x value of 2. So we keep writing it at each step. So we have here the limit as x approaches 2 of x plus 2. That's all we're left with there. And lo and behold, now you can plug it in without getting an undefined result. So the answer here is 2 plus 2. I've now plugged in the x value of 2, so I can stop writing limit as x approaches 2. So the answer is 4. The limit of x squared minus 4 over x minus 2 as x approaches 2 is 4. Let's look at this other example. We have the function x squared minus 3x minus 10 over x minus 5, and we're looking for its limit as x approaches 5. If you plugged in an x value of 5, you would get a denominator of 0, which is undefined. But we can simplify this fraction. How? By factorizing the numerator. It's a trinomial, x squared minus 3x minus 10. I'll open there 2 brackets, and you can pause the video and try to factorize it on your own first. I really encourage that. But I'm going to put here x and x, 5 and 2. Those are factors of 10. Since 5 times 2 is 10, I'll make the 5 negative and the 2 positive to ensure that we would get minus 3x if we simplified it. And in our denominator, I have x minus 5. And so because of this, this x minus 5 can cancel with that x minus 5. So what I have here now is the limit as x approaches 5 of x plus 2. And if I replace x with 5, I get 5 plus 2, which is 7. Now, matriculants, that's how you find a limit. For your enrichment, I want us to discuss again what a limit actually is. So, imagine we had this function, f of x is equal to x minus 2. The graph can be represented by this blue graph, well, now pink graph that I've drawn there. And when we say what is the limit of that x minus 2 function as x approaches 5. Well, if you look at this graph, here we have an x value of 5, say here we had an x value of 4, here we had an x value of 3, and so on and so forth. Here we had 6, here we had 7. The closer the x values get to 5, the closer the y value on the graph gets to 3. That's what that means. So what is the y value when x is 3? It's 3 minus 2, which is 1. So the y value when x is 3 is 1. The y value when x is 4, that's 4 minus 2, is 2. Okay. What about the y value when x is 6? That would be 6 minus 2, which is 4. And the y value when x is 7 would be 5. Okay. So when we move from 5, x values from 5 to 4, x values from 7 and 6, you'll see that the y value is there 5, then 4. And if we moved from the right-hand side, from an x value of 3 to an x value of 4, the closer we make x get to 5, the closer y gets to 3. And so that's why the limit as x approaches 5 of x minus 2 is 3. Because the closer x gets to 5, the closer this graph's y value gets to 3. Now, matriculants, you might be wondering, why does it matter for me to say as x moves closer to 5, the graph moves closer to a y value of 3? Why does that matter if I can just plug in an x value of 5 and I get that the y value is 3? You know, that's because when you get to your first year of university maths, which you will do if you are going to study maths or study anything that will require that you do a little bit of maths, you learn about what we call a piecewise function, something that looks like this, for example. This looks very much like the graph y is equal to x minus 2 that we've been looking at. Where if you gave it an x value of 5, you'd get a y value of 3. Sorry, these are some mistakes there. You'd get a y value of 3 if you gave it an x value of 5. But for some reason, this graph doesn't have a point at a y value of 3 when x is 5. Instead, it has a point at 8. Okay? So we call that a piecewise function, where a piece of it doesn't actually follow the trend of the rest of the graph. Okay, so for that part, doesn't follow the trend. For some reason, the graph goes this way, and then when it gets to 5, it jumps up to there, then it continues this way. Okay, so because of that, on this function, when x is 5, the y value is 8. Okay, but the limit as x approaches 5 of this graph is 3. We can see that the closer x gets to 5, this graph gets closer and closer to a y value of 3. It's just that its value at 5 is 8. Okay, so on this function, when x is 5, y is 8. However, the limit as x approaches 5 is actually 3. Okay, so don't stress yourself about this too much. Like I said, you really don't have to know this like by heart. It's not really going to be tested. You just need to know how to find the limit. Now, see you in the next video where we will talk about first principles, how to find the derivative using first principles.